Oh, actually, yeah, Meg's all done. Luke's done it all except the last question.
Didn't know about until I started class.
Well, neither did Meg.
I'm slow.
Hey, Luke.
Hey.
Have a good weekend?
Yeah, that's pretty good. How about you guys?
Mine was okay. We opened the, well, we didn't open, we had an open house at the hyperbaric chamber. And yeah, we had people, I met people who had decompression sickness from diving and decompressed in the hyperbaric chamber and all that kind of stuff. So it was pretty neat.
Everyone?
So we're just, I guess we're just waiting for Meg here. So the preamble went pretty well for you, Luke?
Yeah.
Yeah. So all that basically you really have to know, if you've got a normal vector, say your normal vector is like 1, 2, -4. The equation of the plane is going to be like 1x plus 2y minus 4z plus d equals 0. And then you can calculate the d just by finding a point somewhere, if you've got a point somewhere on the equation. Oh, there's Meg. Hey, the gang's all here. So Meg, you got 10 on the preamble. No comments.
Yeah, didn't do any penalties.
Yeah, I decided I would set it up without penalties since it didn't really make sense. Okay, so it actually, the preamble winds up asking you to calculate the cross product kind of as a review, but it doesn't really say why you would be calculating the cross product. Does it? No, eh?
No.
So you actually get good at calculating the cross product so that if you've got two vectors that lie on a plane, you can calculate the vector that's perpendicular to that plane. Okay, so as long as you can get two vectors on a plane, you can find the normal vector, and if you find the normal vector, you've got your A, B, and C for the plane. And then you can go from there. So we'll start out, we'll just do a couple of example problems, and we'll talk about distance from a point to the plane. So here's the opening question. Find the scalar equation of the plane containing that line. So the line is given to us in parametric form, and the point 1, 1, 0.
What are the coordinates for the line? It hasn't cleared up yet. I can't do it.
Oh, okay. So the position vector for the equation of the line is -4, 0, and 5.
Okay.
Plus t times 3, 1, and 2.
Okay.
The point that lies on the line is 1, 1, and 0.
Thank you.
So basically, we need two direction vectors from this plane so that we can use the cross product to calculate the normal vector for the plane, because that gives us our A, B, and C. So who can tell me one vector, one direction vector for the plane? Just looking at this one. So 624. How did you get that?
I just substituted 2 and 15. And for the second.
Okay. 624 would be a point that lies on the. That would be a point that lies on the plane.
Right.
And it would lie on the line. But it wouldn't be a vector that's on the plane, or more accurately, a vector that's parallel or in the direction of the plane. So we need two vectors that lie on the plane so that we can take a cross product and find the normal. Vector 1 is really easy. We're just going to use a direction vector. So that's going to be one of the vectors that lies on the plane, or more accurately lies in the direction of the plane. Now we have to look around and see if we've got enough information to find another vector that lies on the plane. So basically, if I've got 2 points that lie on the plane, I can actually calculate a vector that lies on the plane. Now I know the position vector, that position, -405, is on the plane, and I know that this point, 110, also lies on the plane. So what I'm going to do is I'm just going to construct the vector by subtracting tip from tail using those 2 points. Okay, so I'm going to take 110 and I'm going to subtract -4, and 5 to get my second vector. I'm going to get 5, 1, -5. So those are my 2 vectors that lie on the plane. Now to find the perpendicular vector, I'm just going to do the cross product of those 2 vectors. And that's going to give me my A, B, and C. I'm going to do 3, 1, and 2. I'm going to cross that with 5, 1, and -5. So that is equal to, without going through a long song and dance, because I know everybody here can do cross product like nobody's business. So there is my normal vector.
Isn't it 35?
Is it 35? Jeez.
Times 10, or 2 times 5 is 10. -5 times 3 is -15. So 10 plus 15 is 35.
Oh, Meg, you're way ahead of me here. So 1 times 5, 1 times -5 minus 2 is -7. 2 times 5 is 10.
Minus 15.
Minus
Or -15.
-15.
But
It's 25.
never mind.
Hey,
I can't do math apparently.
well, you know what? If you're calculating cross products in your head like that, that's nothing wrong with that. Okay. Who can tell me something about the equation of the plane? Luke, you've been notably silent. Right out. Tell me as much of the plane as you can possibly get here.
About the scalar equation.
Yeah.
it's like ax plus by plus cz plus d equals 0.
Yeah.
And you can kind of cheat because there's like you kind of already have the x, y, a, b, and c values. So
Exactly.
and then you can just find d by subbing in x and z values.
That's right. And we can choose our x, y, and z values. I don't know. That point there lies on the plane, right? 110.
Yeah.
So let's. It's got a 0 in it. That's going to make it. It's got to make it easy, right? So let's substitute that in. Just tell me if I'm wrong, but I'm getting d is equal to negative 18. So pi 1 is negative 7x plus 25y times 2z. Uh-oh. Minus 18. Let's equal 0. Okay. So that sounds perfect. So once again, if you can just get two vectors that lie on the plane, or more appropriately lie parallel to that plane, cross product the vectors, it gives you the perpendicular. That tells you the A, B, and C, and away you go. Okay, well done. There is a formula that tells you the distance from a point to a plane. Now there's a long, like, how you derive that formula. It's not actually all that long, but I don't think we're going to do it just today. But basically, it looks like this. If we have a plane, AX plus BY plus CZ plus D, and we have a point that's X1, Y1, and Z1. So this is just the general formula. We have our A, B, C, and D values. We also have the point. And so when you're using the formula, these are just going to be coordinates over here. You can just calculate the distance with the following formula. So you use the absolute value of like the whole left side of that equation, basically. Or the magnitude of that normal vector. Okay? So this is actually derived just pretty much from that whole system of projections, where you project one vector onto the other. In this case, we've actually projected onto the normal vector. We can project any vector we want that goes from the line to the plane onto the normal vector. And so we wind up with this formula right here. Okay. So, let's use it. So let's find the distance. Let's go from point 2, which is 1, 4, and 7. And we're going to go to the plane that has the equation 2x minus 3y minus 3z plus 9 equals 0. Okay, so we're going to plug everything that we know now into our nicely derived formula. So my A is 2, my B is -3, my C is -3, and my D is +9. My X1 is 1, my Y1 is 4, and my Z1 is 7. So that's all we have to do. Just plug in. It's just plug and play from here on in. So I think, according to my calculations anyway, that's going to all be equal to 22 over the square root of 22. On the top?
Yeah,
Okay.
because you have -12 and -21, and you have a 9 there too. So the negative.
Yep.
Oh,
So we
right
have-
after.
Yeah, so we have an absolute value bracket there, and the reason is you don't usually think of the distance as being negative. So, yeah, so we take the absolute value of that. And we can actually simplify this a little bit. So we can rewrite that because, of course, we don't want a radical on the bottom. 22 divided by the square root of 22 is? Anybody? Luke?
I don't know.
Meg? 22 divided by the square root of 22 is?
Square root of 22, isn't it?
Square root of 22. Okay, really good. Okay, so that's finding the distance from a point to a plane. There's just a formula for it. It's kind of an ugly formula, but you see it's got a lot of like equations of planes and A, B's, and C's in it. All these questions basically have that same trick where you're trying to find a normal vector to the plane to find your A, B, and C. And once you have that, you can calculate D. Sometimes you're going to be finding the vectors that lie on the plane. You'll be given like 3 points. Sometimes you'll be given a direction vector and a couple of points. So you might be doing a little bit of investigation just basically to try and figure out what the normal vector is, or what 2 things or what pieces of information are going to give you the vectors that are on the plane. So we'll keep it nice and simple. This is actually a nice, this is like going to be a nice, quick, easy ending to the semester. So we'll just do the quizzes, and we'll do exercises 1 to 5. And